In this lesson, we're going to discuss the concept of disaster recovery and how it's implemented in your cloud designs. Disaster recovery refers to the process of restoring IT systems, applications, and data after a disruption, such as a natural disaster, cyber attack, or even human error. The primary objective of disaster recovery is to minimize downtime and data loss, allowing organizations to resume normal operations as quickly as possible. There are several strategies that organizations can implement to achieve disaster recovery in cloud computing, including backup and restore, replication, and failover. Backup and restore involves creating regular backups of data and applications and then restoring them in the event of a disaster. Replication involves creating a second copy of the system that can take over in the event of a disaster. Failover involves having a secondary system that can take over in the event of disaster. Disaster recovery is essential in cloud computing as it ensures that the system remains available and accessible even in the event of a disaster. With a disaster recovery plan in place, organizations can minimize downtime and ensure that their applications and services are always available to their customers and users. In cloud design, disaster recovery is becoming increasingly important as more organizations rely on cloud services for mission-critical applications and data. Cloud computing provides several advantages for disaster recovery, including scalability, flexibility, cost savings, and improved data protection. Scalability. With cloud computing, organizations can quickly increase or decrease their computing resources as needed, making it easier to handle spikes in demand during the disaster recovery situation. Flexibility. Cloud-based disaster recovery or DR solutions can be deployed quickly, allowing organizations to rapidly respond to changes in disaster recovery needs. Cost savings. DR in the cloud can be more cost-effective than traditional DR solutions because organizations can pay only for the resources they need when they need them. Improved data protection. The cloud provides multiple layers of data protection, including automatic backups, snapshots, and redundancy, which can help organizations recover from the data loss or corruption more quickly. Now, there are three main types of disaster recovery strategies used in cloud computing. These are known as hot, warm, and cold sites, and they are used in both cloud-based and on-premise solutions and designs. These three levels refer to the level of preparedness and infrastructure that is available for use when a disaster occurs. A hot site is a fully functional, alternate location that is constantly maintained with the latest hardware, software, and data. In the event of a disaster, users can immediately resume operations from the hot site without any downtime. This type of disaster recovery solution is best suited for organizations with critical operations that require a quick and seamless recovery. However, hot sites are often the most expensive option and require constant upkeep to ensure that they remain ready for use. A warm site is a partially functional alternate location that has some of the necessary infrastructure and equipment in place, but may not have all the latest hardware and software. In the event of a disaster, an organization may need to install additional equipment or restore data before resuming operations from a warm site. Warm sites offer a lower cost alternative to hot sites and can provide a reasonable recovery time, but require more preparation and planning. A cold site is a pre-prepared location with basic infrastructure, such as power and network connections, but without any hardware, software, or data. In the event of a disaster, an organization must install its own hardware and software and restores data before it can resume normal operations from a cold site. Cold sites offer the lowest cost option for disaster recovery, but require the most preparation and planning, and typically results in the longest recovery times. In cloud-based designs, hot, warm, and cold sites can be used in a number of ways to support disaster recovery. For example, an organization can use a hot site in the cloud to provide real-time data replication and immediate access to critical applications and data in the event of a disaster. A warm site in the cloud can be used to provide partial infrastructure and data. This allows the organization to recover from a disaster in a shorter amount of time. A cold site can be used to store backups and snapshots of critical data, allowing the organization to recover its data in the event of a disaster. When implementing disaster recovery in cloud computing, organizations should consider their specific needs such as availability, cost, ease of management, recovery time objectives, and overall disaster recovery strategy. It's also important for organizations to understand that disaster recovery is not a one-time decision and it can be changed as per the organization's needs. The organization's needs, goals, and requirements can and typically will change over time, so it's essential to constantly review and evaluate the disaster recovery plan to ensure it continues to meet the organization's needs. Not only should these organizations review the plans, but they should also implement testing to ensure that it works in a real type of scenario. So, remember that disaster recovery is an important aspect in cloud computing, and organizations must carefully consider the different options when implementing cloud computing. With proper understanding of disaster recovery and its benefits, organizations can best select disaster recovery strategy to meet their specific goals to ensure that systems remain available and accessible in the event of disaster by leveraging the resources of the cloud.